Least square method, best fitting parabola. Say we have a 4 points through which we like to draw the best fitting parabola. First point is minus 2.6. So it's 1, 2, 1, 2, 3, 4, 5, 6. So somewhere here. It's point A. We have a point B, minus 1, 2. So somewhere there. Then we have C, 0, 1. There. And we have point D, which is 1, 3. 1, and I have here point D. So a best fitting parabola could be something like this. I'm not sure, but this could be. Well, you see that there are always errors. Here's an error, we have an error over there, we have an error over there, and there's an error. So this error is called E1, error 1, error 2, error 3, and arrow 4. So the thing is, how can I move this parabola whatever way, up, down, left, right, so that the sum of the arrows is minimal. So that's what we're going to do. First thing is, we would like to know the formula is ax squared plus bx plus c. Never mind, you can use the US system as well. It says a plus bx plus c x squared, which is more logical because the a is always the a and the b is always connected to the x, but never mind. So fill in these coordinates. So this is always the x coordinate, that's the y. So we have a 6 is minus 2 squared is 4a minus 2b plus c. We have a 2 is minus, it's minus 1 squared is 1a minus b plus c. 1 is 0a plus 0b plus c, and the last one is 3 equals a plus b plus c. So this is an interesting one, because students say, okay, so now we can conclude that c is 1. Yes, you can do so, but then you say the parabola has to go through point C. So I pin the parabola through point C. That's not what I want to do, because I'm not sure that that will give the best solution. So no, C is not 1. We will see what it will be. Next step is to put a whole bunch into a matrix. So we have a 4, 1, 0, 1. See, here is nothing, but it says a 1, of course. Then we have the B is minus 2, minus 1, 0, and 1. The C, 1, 1, 1, 1. Multiply by A, B, C, which we should like to solve, equals, and then we have the factor over here, 6, 2, 1, 3. Right. So this is the A matrix times a factor x equals B. So we see we have a 4 rows, 3 columns. The matrix is not square, so we cannot find the inverted matrix. So what we're going to do is to make it square. So we have AT times A times X. So also here is AT times B. So I would like to get rid of this part over here because I only want to know the X. So we do AT times A minus 1 times AT times A times X. So this should equal the unit matrix, which is in fact 1 in matrix multiplication. So I put here, I put this extra, so I put it here as well extra, so AT times A inverted times what was already there, AT times B. So in the end I have the X equals AT times A times inverted times AT times B. So you put this in a computer, your calculator, whatever. So having done that, and maybe you should stop the video and try that, I found myself that the X is something like 25 divided by 18, 1/3 and 7/6. Probably you have something with decimals, but you can ask your calculator, just put it in fractions and it will do. So now I found the formula of the best fitting parabola, which is the A, which is here because this is the most upper of the, so this is the A, so it's 2518 x squared added by 1/3 x added by 7 divided by 6. So this is your formula. Okay, that's one. I would like to know how well does it fit. So you can say that if you have this A times x equals b, well, that's not completely true because there is some kind of error over here, which is consisting of all these errors e1, e2, 3 and 4, which makes it equal. So now I can say, oh, then the error is something like b minus a times x. So what I would do is store this x as a matrix as well. In my situation, this would be a matrix C. So this is my matrix A, and this part over here is my matrix B, capital, sorry. So storing this one, putting it there, gives something like minus 1 divided by 18. I have a 1 divided by 9, minus 1 divided by 6, and 1 divided by 9. And actually, these numbers, so here I find minus 1 divided by 18. This error is something like 1/9, so I should go up. Sketch is not what it should be. Third one is minus 1 divided by 16, and the last one over here is 1 divided by 9. So we have found the best fitting parabola, but besides that we can also say this is the error which comes along with it. So not completely happy yet. We can also say, is it possible to calculate the total error, which is in fact the total of these errors squared. So check if I can move my screen a little bit. No, doesn't work. So I say the E is the square root of E1 squared plus E4 squared, something like that. So you put all these things square root, and then having done that, I get something like 0.044, which says something about the total error in this fitting question. Okay, that's about this video. I hope it was useful for you.